Right, welcome back. Today we're going to continue talking about writing systems of equations from a story problem, except today we're going to kind of be looking at two different possibilities. Now, yesterday I had it all set up to where standard form was the key. Everything was in standard form, and today there's going to be a mixture, standard form and slope-intercept form. So let's talk about the difference between the two. Now, standard form, the one at the top, the ax plus by equals c, the main idea of when we use this is when the total amount is unknown. We are putting together item 1 and item 2, whatever those are, whether it's a box of small oranges and a box of large oranges, or whether you're buying candy versus gum and things like that. And the total is known. You know exactly how much you've spent, and you're trying to work it backwards to find out how much each of the items were. Now, slope-intercept form is a little bit different. What makes it special is you already know the total. You have the final amount. What you don't necessarily have is how much time or how much something was put into it. So with the slope-intercept form, the two pieces of information that you have is a unit rate. Usually that revolves the word per, 50 miles per hour, $3 per hot dog, whatever it is. There's usually a unit price or a unit rate. And then there's also some initial one-time fee. Like you go to the, I don't know if you've ever been to like the Three Rivers Festival or the Midway or, an amusement park where you can, buy a wristband and get in. And then once you're in, you can ride rides, but you got to pay for your more drinks and things like that. But that one-time fee of buying the all wristband, all the rides included type of thing. Or if you have a plumber come out to your house, and they usually charge you like $25 just to show up, and then an additional $8 per hour or $12 per hour or something like that. So again, you can tell the difference by the way the equation's written. So let's do one of each so we can see how we can decipher which one to use. All right, so first example. Maria was buying vegetables to plant in her garden. She bought 6 tomato plants and 4 pepper plants for $21. The next day, she went back and bought 2 more tomato plants and 2 more pepper plants for $8. How much does each type of vegetable cost? So, excuse me. If it's me, the first thing I'm going to do is set up a variable. I'll use X for tomato and Y for pepper. All right, then I want to set up my equations. In this case, I'll have an equation for day 1 and a separate equation for day 2. So on day 1, it says she bought 6 tomato plants, so that's 6x, and 4 pepper plants, so plus 4y, for a total of $21. And the fact that we had the total is how I knew to use standard form. They gave us the total. Right? So that's what you're looking for. Did they give us a total? So the next equation. The next day, she went back, bought 2 more tomato plants and 2 more pepper plants for $8. So again, we have the total. So let's fill it in. She bought 2 of each, 2 peppers, 2 tomatoes, and there's our setup. All right, now unlike yesterday, this one doesn't quite line up. If I add them or subtract them, the letters won't cancel. So I need to find a common multiple. For my x's, my common multiple would be 6. And for the y's, my common multiple would be 4. So it doesn't really matter which one you choose. Whichever one looks better to you, I'm going to go ahead and choose the x's being 6. So that means the top one I don't have to make any changes to. It's already got 6x. But the bottom one, I would like to force this into being negative 6x so that it cancels out with that positive 6x. So what have I got to times it by? Well, it turns out I've got to times it by negative 3. So times the whole bottom equation by negative 3. All the numbers by negative 3. Now when we add things up, got negative 2y equals negative 3. Divide both sides by negative 2. And I get y equals 1.5. Now since y was the cost of the pepper plants, we are talking $1.50. Not 1.5, but $1.50. And now that we know the price of the pepper plants, we can go back and substitute either original equation, I'll choose the day 2 equation, and replace the price of the pepper plants with what we now know of $1.50. So if I bought 2 of them at $1.50 each, that was $3 spent on pepper plants, minus that from our total. That means that the 2 tomato plants cost me a total of $5. Divide by 2, and I get x equals 2.5. But again, that's the price of tomato plants. So in the end, we now know that pepper, whoops, if I spell right, the pepper plants were $1.50. And we also now know that the tomato plants were $2.50. Make sure your word problems have word answers. All right, now let's try one of the other kind. This one says, to rent a moped at the beach A, it just should be at beach A, costs $10 plus $2 per hour. So there's a fee to just get the moped, and then an additional fee based on how long you ride the moped. At beach B, it costs $15 plus $1 per hour. So they're charging you a little bit more up front, but a cheaper per hour rate. How many hours riding would make the price at the beaches the same? So we don't know when those are equal to each other. So, because in these ones we don't know the total, I don't know how much it cost, but I do have this initial fee amount, and I have this $2 per hour. That's telling me again that I should have 2 equations set up in slope-intercept. So in part A, y equals, well again I don't know the total, but I do know that first one, that beach A, it costs $10 to start, plus $2 per hour. Now that might look backwards to you. If you would prefer that to look like slope-intercept form, the 2x would have came first and the 10x would have came last, but same idea. Beach B, it costs $15 plus $1 per hour. And what we're really seeing here is that the x is standing for hours. That's the thing that changes, our variable. And again, if you don't like the order of that, you can switch it, make it look more like slope-intercept form. Now, how do I solve this kind? Well, you could use substitution. Anytime you have one of them that's been solved for x or y, substitution is your best method. So what that means is the 2x plus 10 should substitute in any other place where you see a y. So that would go there. So at the second equation now becomes 2x plus 10 equals x plus 15. Solve. Get my like terms together first. And then get rid of the plus 10 with a minus 10, not 15, but 10. Okay, and I get x equals 5. And remember, x stood for hours, so we're talking 5 hours. That's what would make them the same price. If you did 5 hours, they're equally priced. If you do less than 5 hours, one of them's better. More than 5 hours, the other one is better. All right. Hopefully it makes sense, the difference between the two. You should have a couple of each kind of problem today. So you know where to find me if you need any help. Good luck.